This is the Fairchild Republic A-10 Thunderbolt II, also known as the A-10 Warthog, America's ultimate tank killer and a guardian angel for ground troops. The plane can deliver devastating firepower, all while surviving tremendous punishment. But what makes this awkward-looking plane? One of the most beloved and effective close air support aircraft ever built. We've modeled the A-10C in minute detail to explore this military marvel inside and out. With its distinctive twin-engine design and a powerful 30mm cannon. That is bigger than a Volkswagen Beetle. The Warthog is unlike any other aircraft in the world. In this video, we'll be focusing on the modernized A-10C version that showcases the best of this aircraft's close air support technology. I'm David Webb, and this is Blue Paw Print. The Warthog's airframe is a masterpiece when it comes to survivability. The plane measures 53 feet 4 inches long and stands 14 feet 8 inches tall. It has a wingspan of 57 feet 6 inches and a wing area of 506 square feet. The A-10 weighs 24,959 pounds when empty, but it can take off at a maximum weight of 50,000 pounds, which means it can carry almost as much ordnance as it weighs. The A-10's design is about being cost-effective and tough on the battlefield. About 95% of the fuselage features stress and corrosion-resistant aluminum alloys. With sections riveted together, the designers avoided composite materials and opted for flat plates for much of the aircraft's skin. These are interchangeable between the left and right sides. The fuselage features forward, center, and aft sections. The forward section is home to the giant GAU-8 cannon system, and the entire underside swings open for easy maintenance. The center section holds the main fuel tanks. The aft section contains the auxiliary power unit, which supplies electrical power and compressed air for starting engines and ground maintenance. The A-10's wings are perhaps its most distinctive feature and are designed specifically for low-speed, low-altitude missions. They use a 3-spar design, a straight center section, upward tilting or dihedral outer sections, and wingtips that droop down, called Herner wingtips, which reduce drag and improve airflow over the wings. The fuel tanks are built into the straight center sections, in addition to the main tanks found in the fuselage. The outer sections of the wings tilt upward at a 7-degree angle for improved stability during flight. They're constructed using strong, yet lightweight honeycomb panels. There are similar structures all over the plane. The Horner wingtips serve multiple critical functions. They work like winglets, cutting down on drag and helping the A-10 to stay in the air longer, which is essential for close air support. The drooped design boosts the wingtips' efficiency, making the ailerons more responsive and improving the plane's maneuverability at low altitudes. This setup also provides STOL capabilities, or short takeoff and landing. Fully loaded, the A-10 can take off on a runway as short as 4,000 feet, 1,219 meters. But wings are positioned low, which allows for more weapon-carrying pylons without compromising low-level handling. The wings are straight with no sweep because the A-10 was built to be a subsonic aircraft focused on loitering in battle rather than moving at high speeds. The A-10's control surfaces are larger than those on most similar aircraft. and are there to handle the tough demands of low-speed, low-altitude combat. The ailerons are a standout feature, stretching across nearly half the wingspan to provide exceptional control even when flying slowly. These ailerons are split and also work as decelerons, opening up above and below the wing to act like air brakes during maneuvers or landing. Single-swatted Fowler-type flaps, an extension of the wing that runs along the rear, are located inboard of the ailerons. They're hydraulically operated and have 3 settings to improve airflow and give extra lift at lower speeds. On production models, these flaps are set to 20 degrees, which is half of what the original prototypes had. They're also interchangeable. The A-10 can still fly, even if one flap is completely destroyed. The A-10's flight controls use 2 independent hydraulic systems plus a mechanical backup with cable routing designed for maximum combat survivability. This cable setup allows for backup control even if the hydraulic power is lost, meaning pilots can still fly the aircraft home using manual mode. In an emergency, pitch and yaw control engage automatically, while roll control remains in the pilot's hands. The tail, or empennage, has twin vertical stabilizers. It allows the aircraft to stay in the air even if one of the vertical stabilizers gets taken out by enemy fire. Both rudders and elevators are made from the same honeycomb composite as the outer sections of the wings, which makes them lightweight yet strong. The elevators also have trim tabs on their outer edges, and the whole tail assembly, again like the wings, is designed so that parts can be easily swapped between the left and right sides. The A-10 is powered by 2 General Electric TF34 GE100 turbofan engines, each producing 9,065 pounds of thrust. The engines are mounted high and behind the wings. The way the exhaust nozzles are angled up helps reduce jet blast on the ground and keeps the aircraft's heat signature lower, making it harder for heat-seeking missiles to lock on. By having the engines in separate nacelles, the design makes it less likely that a single hit could take out both engines at once. Each TF-34 engine breaks down into 5 main parts, making maintenance easier. These vanes adjust their angle automatically to control airflow. The annular combustion chamber is made from tough nickel alloy parts for a longer lifespan, and the turbines provide reliable power, allowing the aircraft to go from idle to full throttle in just 10 seconds. All 4 main fuel tanks are placed near the center of gravity and are separate from the fuselage, so any projectiles have to get through the outer skin before hitting a fuel tank. The wing tanks can hold a total of 622 gallons, while the hull tanks can hold 1,022 gallons, bringing the total internal capacity to 1,644 gallons. The fuel transfer lines are designed to seal themselves if damaged, and check valves stop fuel from flowing into any compromised tanks.